In this tutorial I'm going to discuss how to select specific amino acids in Pymol. The structure we're looking at is chymotrypsinogen, which is the inactive precursor of the protease chymotrypsin. We know from textbooks that the active site serine residue is residue 195, but if we weren't sure about the numbering, we could try the command SELE res n SER. We could also replace SER with any three-letter amino acid code. Once we hit enter and click the select box, we see that every serine residue in the enzyme is highlighted. In fact, we can immediately see that this serine residue is part of the catalytic triad with a histidine residue and an aspartic acid residue. The numbering between textbooks and PDB structures may not always align. For example, if we're looking at homologous enzymes between different organisms, the structure can vary, or researchers might deliberately alter the sequence by including purification tags and so forth in their coordinates, and this could alter the original sequence. If I wanted to see which residues were nearby this histidine and could potentially interact through hydrogen bonds, I could try the command SELE res I 57 around 3.5. And when I bring up the select box, I can see immediately all of the atoms within 3.5 angstroms have been selected, and it'll be much easier to pick out hydrogen bonding partners from here. I can also use a similar command, SELE res I 57, to select that residue itself, or I could pick it out from the sequence viewer. And as always, middle clicking on that residue in the sequence viewer or within the graphics display will center on it. I can select a range of residues with another similar command, SELE res I. Let's select residues 47 through 67. And once we bring up the select box, we can see that on either side of this histidine, residues are selected in the defined range. If I wanted to locate disulfide bonds, for example, I could try the command with cysteine, and it looks like we do indeed have some disulfides out here. If I wanted to find a salt bridge, I could search for all of the positively charged amino acids of one type or all the negatively charged amino acids of one type. So let's try aspartic acid. And it looks like we may have a salt bridge here between this aspartic acid residue and this histidine residue. Likewise, I can do this with nonpolar amino acids, such as leucine. Bring up the select box, and this will help me find hydrophobic patches between nonpolar residues. I can see there's a major patch here that involves leucines, a tyrosine ring, the methyl group of a threonine, and a disulfide bond. A good indicator that these are actually involved in hydrophobic interactions is if you show them in spheres, the radii of the spheres will be touching, and it looks like I even left out a couple of residues such as alanine here. So the radii are very close to touching. So I hope these additional commands are useful to you in generating images in Pymol. Do your best to be creative, informative, and don't forget to have fun.